So today we will go to chapter 2, that is partial derivatives and differentiability. So what do we mean by partial derivatives? So there are two partial derivatives of first order. So that means what, suppose we have let f of f be a real valued function of two variables x and y. Okay. F is said to be partially differentiable with respect to x if limit xy tends to ab, limit xy tends to ab, limit h tends to 0, partially differentiable with respect to x at ab if limit h tends to 0, f of a plus h b minus f of ab upon h is exist and finite. So f is real valued function of two variables x and y. F is said to be partially differentiable with respect to x, at ab if limit h tends to 0, f of a plus hb minus f of ab upon h is exist and finite. It is denoted by dou by dou x of f at ab or just simply fx ab. So thus fx ab dou by dou x of f at ab is same as limit h tends to 0, f of a plus h b minus f of ab upon h. So this is what partial derivative with respect to x. What you did here, you are increase your x coordinate by h and other thing as it is and upon h. Just you know that the derivative for f prime x, this is what limit h tends to 0, f of x plus h minus f of x upon h, right? This you know, this is the first principle, and with the help of the first principle you have to write the functions, and you know that how to find a derivative by using the limit or by using the first principle of the one variable. The same thing here, what you are differentiating with respect to, so therefore what here you are increasing your x coordinate and then this is right. So same thing here, right? So now we differentiate with respect to y now, right? So we'll write the definition with respect to y now. Okay. The same thing here. Let f be a real valued function of two variables x and y. F is said to be partially differentiable with respect to y now. At ab if limit h tends we'll take k now here. K tends to 0. So what you have to do? You have to increase your y coordinate by k only. So this is a b plus k. Your y coordinate is b now. It is increased by k. It exists and finite. It is denoted by fy at ab or dou f by dou y at ab dou f by dou f. So therefore fy at ab is equal to limit k tends to 0. For y we will use this notation. We will use this the letter as k now. F of a b plus k minus f of ab upon k. So this is the partial derivative with respect to y at ab, right? So now we write the general derivative now. Partial derivative. This is at a point. If you want to find the partial derivative of the function at a particular point, then use this formula. Just we write the general now. This is what fx. This is dou f by dou x. It is also denoted by. You may say this is what day y by day by x, whatever this one. So this is what limit h tends to 0. Now we have two variable function x y. What we'll do? We'll increase your x coordinate by h now. Y will be add this f of x y upon h. Right? This is the general. Right? For any function you can differentiate over this. This is what at any point now this is. So fy dou f by dou y is same as what? Limit k tends to 0. Limit k to 0. What you have to do? You have to increase your y coordinate by k. So this is what? Y plus k minus f of xy upon k. So suppose we have three variable functions and we have to find this one. So suppose in this is right, dou f by dou x. We have three variable functions. So we write limit k h tends to 0 f of, just you have to increase your y coordinate only. All other variable as it is. So y z minus f of x y z upon h. Right? So fy. So dou f by dou y. What you have to do here? Limit k tends to 0. You have to increase your y coordinate by k. So this is f of x y plus k z minus f of x y z upon k. Suppose you have to differentiate with respect to z now. This is what? Partial derivative with respect to z. Dou f by dou z is equal to limit r tends to 0. Whatever the letter we will use, r tends to 0. We have to increase your y, z coordinate by r now. X, y, z plus r minus f of x, y, z upon r. Right? So if you want at a particular point, just what? Replace x, y, z as a, b, c. So if you want to find partial derivative with respect to at point 1, 1, 1. So what you have to write the 1, 1, 1. Then this is 1 plus r minus 1, 1, 1. What are this here like this, right? If you want to find partial derivative with respect to x, y, z at a particular point, just write x, y, z as that particular point. This is the general formula. You should remember this. Okay? So with the help of this one, you have to find partial derivative at a particular point. Okay? So we take an example so that you will understand the definition. So use the definition of partial derivatives as limit to find fx xy and fy xy if f of xy is equal to xy square minus x cube y. Okay. So what you have to write? This is a two variable function. We'll apply the formula. Now solution. Given that f of xy is equal to xy square minus x cube y. Okay. So we write here fx. This is what? Limit h tends to 0. So write the formula. F of x plus h y minus f of xy upon h. Put the value of this, right? F of x plus h y, and this is your f of xy. So this is what? F of xy is this, right? So this is what? Limit h tends to 0. So we have to write this one. We will write in bracket. F of x plus h. That means what? Replace x by x plus h and y by y as it is now. So x plus h y square minus x plus h cube, your y. Right? This is your f of x plus hy minus f of xy as it is. So xy square minus x cube y upon h. So what we do? we will expand this. What is our aim? To evaluate this limit. That means what? We have to take h common from the numerator and then h get cancelled. Then you are ready to find the limit of the function. So we will expand this. So limit h tends to 0. So expand this. Simplify all these things. So here what? Y square. So this is what? X y square plus h y square. Now what is a? A plus b bracket cube is what? A cube plus b cube plus 3 a square b plus 3 ab square. We will apply that. Okay. So and see the minus sign there. That means all terms are negative, and then you have to multiply by y now. So what then? Minus x cube y. You have to multiply by y. Minus h cube y. Right? Then 3. Then you have to write the minus now. 3. The square of the first one. The square of the first one. Second will be as it is, and you have to multiply by y now. Minus 3. First will be as it is. Square of the second, and y will be as it is. Right? Then minus xy square minus x cube y. Minus x cube y upon h. Upon h. Upon h. Now see here, the term which do not contain h should get cancelled. Right? If it is not getting cancelled, that means you made mistake somewhere. Now see, this is xy square. This is a term not containing h. Now see, this is xy square. They are equal, right? And here minus sign, so it get cancelled. This should get cancelled. All your f of xy should get cancelled. Right? Then this is term x cube y do not contain the h, so it is also get cancelled. Now see, all the rest are containing h. So we write here limit h tends to 0. Just we will write all the terms. Rest of the terms what? Hy square. Take the care of the sign. H cube y minus 3 x square hy minus 3 x h square y. Now see here, all term contains h. Right? So now we divide by h to each term now. Limit h tends to 0. Divide by h. So what we get? Y square minus h square y minus 3 x square y minus 3. H get cancelled. We have to cancel this 3. These 3 h y. Right? Now put h is equal to 0. Because now this is not 0 by 0 form. You can put h is equal to 0. So if you put h is equal to 0, so what we get? Y square. Here h is equal to 0. That means this is what? Minus 3x square y. So this is your required answer. Right? So this is your fx. This is your fx. Now how to check whether your answer is correct or not? Right? Now see, what is your function? What is your function? Your function is what? Xy square minus x cube y. Right? We have to differentiate this with respect to x. We have to differentiate this with respect to x. That means what? So this is just like as a single variable function. So what you have to do for? You have to keep all other variables other than x as a constant. Right? So that means your y square is constant. Here y is constant. So see, what is the derivative of this term then? So derivative of this y square as it is. Derivative of x is 1. So see your y square. Your minus y. Derivative of x cube is 3x square. Your y is a constant. It is as it is, right? So that means what? This is correct, right? So derivative of this is what? Derivative of x is 1. So y square is constant. So this is as it is. Then minus derivative of x cube is 3x square. Is 3x square. Your y is constant. So y will be as it is, right? So now we'll find fy now. You have to find fy. Okay, so this is your function. We write a formula for fy. So this is what? Limit k tends to 0. F of, you have to increase your y coordinate by k minus f of xy upon k. So this is limit k tends to 0. Limit k tends to 0. So you have to write this value. You have to replace y as what? Y plus k now. We write in bracket x y plus k square minus x cube y plus k minus your original function as it is now. Xy square minus x cube y upon k upon k. Right? Now we'll expand. So what we have to do? Actually, we have to take the k common now. That means what? If you expand this one, the term not containing k should get cancelled. Right? So this is what limit k tends to 0. We will expand this. What? X y square plus twice x y k. This is what? Twice y k, and you are x is there, plus x k square minus x cube y minus x cube k minus x y square. Keep this bracket as it is. Now see, the term do not containing k now. xy square is here, right? So write first upon k. This get cancelled, this get cancelled. This is term containing x. This is the term not containing x now, not containing k. So get cancelled now, right? Okay. So this is what then limit k tends to 0. We'll write all the terms. So twice x y k plus x k square minus x cube k upon k. So this is limit k tends to 0. Now see here, each term contain k, so we divide by k to each term. So what we get? Twice xy plus x minus plus xk minus x cube, right? And this is equal to what? If you put k is equal to 0 now, so twice xy minus x cube, right? So this is your fy. Now check whether our answer is correct or not. So what is your function? This is your function xy square minus x cube y. We differentiate this partially with respect to y. So when we are differentiating partially with respect to y, we have to keep x as a constant. So your x is constant. Here I have put y is twice y minus x cube is constant. Derivative of y is 1. Now see, this is what? Twice xy minus x cube. So twice xy minus x cube. So whatever the answer we get is the correct. So only part is what? We have to evaluate the limit. Expand something like this. This is a simple algebra, right? So I hope that you can do this one. You can solve the number of problems so that your idea will be clear. So and now you know how to check your answer is correct. Not only you have to what? Only the problem. What is your problem actually? To expand something, right? This is a simple algebra to collect the term. That is your problem, right? So try to solve some problems. Okay. So we'll take one more problem and then we'll go to the next problem. Next type of the problem. So find fx and fy by using definition of limit for the function f of xy is equal to 3xy plus x square plus y square. Suppose this is your function. Okay, so you find this. So you know that what is your effect. Just we try for this one. So if the question is not like this, then directly you can differentiate within the line. So what is your answer? Expected answer we write. We are differentiating with respect to x. What is your expected answer? This is what? 3y. Because derivative of x is 1. So derivative of x square is twice x. And derivative of y square is 0. Because y square is constant. Okay, so we'll find this. So fx. First we write solution. Given that f of xy is equal to 3xy plus x square plus y square. Okay, so fx is equal to limit x tends to 0 f of x plus h. First write the formula, right? Write to the formula. You should remember the formula. Now put the value of f of x plus hy, and f of xy will be as it is now here. No problem here. What? Limit h tends to 0. We will put the value of x and x plus h everywhere now. So 3 x plus h y plus x plus h square plus y square minus 3xy plus x square plus y square upon h. We'll expand. So limit h tends to 0. So 3xy plus 3hy plus expand is x square plus twice hx plus h square plus y square minus 3xy plus x square plus y square upon h. So this is equal to limit h tends to 0. So the term not containing x should get cancelled. Now these all terms should get cancelled. So 3xy, see 3xy here get cancelled. Now this is containing x. So x square see x square get cancelled. Now here y square, this y square get cancelled. Right? Now see the remaining term is what? 3hy plus twice hx plus h square upon h. So this is what? Limit h tends to 0. Right? So h get cancelled. So this is what? 3y plus twice x plus h. Okay. Now we put h is equal to 0. What you get? 3y plus twice x. Now see here, they will turn it. Right? So we are through. Now we'll find the partial derivative of x with respect to y. Okay? So fy is equal to limit k tends to 0 f of x y plus k minus f of xy upon k. Just find the value of this one. Limit k tends to 0. 3x y plus k plus x square plus y plus k square minus f of xy. Just write it. 3xy plus x square plus y square upon k. So this one limit k tends to 0. 3xy plus 3xk plus x square plus y square plus twice yk plus k square minus this will be as it is upon k. So this is limit k tends to 0. Just simplify this. This can cancel, this can cancel, this can cancel. Right? The term not containing k get cancelled. So this is 3xk plus twice yk plus k square upon k. So this is limit k tends to 0. 3x plus twice y plus k plus y square. So this is 3x plus y. Again the answer is what? If you are requested this one, so this is what? 3xy derivative of 3xy is what? 3x plus y square. So I hope that you can solve a number of problems, right? So only problem is here what? You have to arrange the terms. You have to write the exact value of this one and to evaluate the limit. This is the main part, right? I hope that you can do this one. Just try to solve the number of problems. Okay? So we'll stop here.